Hello gardeners, welcome to the Living Soil Lab. Your garden soil is probably starving and you don't even know it. We're so focused on what we add to the soil, we're missing the secret ingredient that builds it from the ground up, literally. Prepare to have your mind blown as we unveil an ancient grain that's revolutionizing soil health and creating living, thriving ecosystems in your backyard. The Great Soil Myth. Why our gardens are starving. Most gardeners operate under a fundamental misunderstanding about soil health. We've been conditioned to think of soil as an inert growing medium that simply needs the right balance of nitrogen, phosphorus, and potassium to produce plants. This reductionist view has turned living, breathing ecosystems into what amounts to dead dirt, a sterile substrate that requires constant inputs just to function. The truth is far more complex and beautiful. Beneath every square foot of healthy soil exists a universe of microbial life, bacteria, fungi, protozoa, and nematodes, all working in intricate relationships that make nutrients available, protect plants from disease, and build soil structure. When we rely solely on synthetic fertilizers or even basic organic amendments without considering this underground ecosystem, we're essentially keeping our soil on life support rather than helping it thrive independently. The soil microbiome functions like the gut microbiome in humans. Just as we need diverse beneficial bacteria for optimal health, soil needs its own complex community of organisms to process nutrients, communicate with plant roots, and create the conditions for sustained fertility. Modern agricultural practices, including excessive tilling, monoculture cropping, and chemical applications, have decimated these communities in most garden soils. Even a lot of organic gardens end up with depleted microbial populations, and that's because we've forgotten one crucial element. Plants themselves are actually the primary feeders of soil life, and, well, some plants do this job extraordinarily well. So, enter Einkorn. It's the most ancient cultivated wheat species going back over 10,000 years to the Fertile Crescent. While, modern wheat varieties have been bred mostly for yield and ease of harvest, Einkorn still holds on to characteristics that make it a real powerhouse for soil regeneration, and honestly, the key lies in its root system. But the real magic happens at the molecular level through root exudates. As Einkorn grows, its roots secrete sugars, proteins, enzymes, and organic acids into the surrounding soil. These exudates serve as food for specific bacterial and fungal species that form partnerships with the plant. Think of it as the plant paying rent to its microbial neighbors with liquid carbon, the currency of the underground economy. Einkorn is particularly generous with these exudates, releasing up to 40% of the carbon it captures through photosynthesis directly into the soil. This carbon-feeding frenzy attracts beneficial organisms in massive numbers, creating what soil scientists call the rhizosphere, a zone of intense biological activity surrounding plant roots. The relationship between Einkorn and mycorrhizal fungi deserves special attention. These fungi form thread-like networks called hyphae that extend the plant's root system by orders of magnitude, accessing nutrients and water the plant could never reach alone. In exchange, Salminaikin funds, plant redistos and funds, pribar arvor. Fungi, with carbon from photosynthesis. Einkorn forms particularly robust associations with arbuscular mycorrhizal fungi, the ancient lineage that helped plants colonize land 400 million years ago. When you grow Einkorn, you're not just planting a grain, you're inoculating your soil with fungal networks that will benefit every subsequent crop you plant. Integrating Einkorn into your garden system is, honestly, remarkably straightforward. The most effective approach is using it as a winter cover crop, sowing seeds in late summer or early fall, depending on your climate. Just broadcast the seeds at roughly 2 to 3 ounces per 100 square feet, then lightly rake them into the soil surface or cover with a thin layer of compost. As temperatures cool and the rains begin, einkorn will germinate and establish its root system throughout the winter months, when your garden beds would otherwise sit bare and, well, vulnerable to erosion. Throughout winter, those roots are working tirelessly underground, pumping exudates into the soil and feeding microbial populations even in cold temperatures. So, come spring, you have several options. You can allow the einkorn to mature and harvest the grain for your own consumption. After all, it's incredibly nutritious and, honestly, easier to digest than modern wheat. Alternatively, you can cut it down before seed formation and use it as a nitrogen-rich mulch, or incorporate it shallowly into the top few inches of soil where those roots will decompose and add organic matter. Many gardeners use the crimping method, where you roll or bend the stems at ground level, creating an instant mulch layer while leaving roots intact to continue feeding soil life as they decompose. The visual transformation in soil health after a season of einkorn is, well, pretty remarkable. Soil that was previously hard and clumpy becomes noticeably more friable and crumbly. When you dig into einkorn-amended beds, you'll see increased earthworm activity, better aggregation of soil particles, and that characteristic dark, rich color that indicates high organic matter content. I've worked with gardeners who transformed compacted clay into workable loam in just 2 seasons by rotating einkorn through their beds systematically. One market gardener in Oregon reported a 50% reduction in irrigation needs after 3 years of incorporating einkorn into crop rotations, attributing the change to improved soil structure and water-holding capacity created by the grain's extensive root system. The implications of einkorn cultivation extend far beyond individual garden productivity. In the context of regenerative agriculture, this ancient grain represents a tool for actively reversing soil degradation on a planetary scale. Every acre planted to einkorn or similar deep-rooted grains sequesters atmospheric carbon, locking it away in stable soil organic matter rather than contributing to greenhouse gas accumulation. The carbon captured through photosynthesis doesn't just feed microbes temporarily, it becomes part of long-lasting humus compounds that can persist in soil for decades or even centuries. This carbon sequestration function connects your backyard garden to global climate solutions. When enough farmers and gardeners adopt practices that build soil carbon, we create a meaningful drawdown of atmospheric carbon dioxide. Current research suggests that restoring soil health on global agricultural lands could sequester enough carbon to offset a significant percentage of annual human emissions. Your decision to plant einkorn isn't just about better tomatoes next summer, it's a tangible action toward planetary healing. The nutritional implications also matter. Soil built through biological processes rather than chemical inputs produces food with dramatically different nutrient profiles. Plants growing in biologically active soil have access to a broader spectrum of minerals and trace elements which they incorporate into their tissues. When you eat vegetables grown in einkorn-enriched soil, you're consuming food with higher nutrient density, better mineral ratios, and potentially beneficial compounds created through complex plant-microbe interactions. This creates a direct line from soil health to human health, closing the loop in the most fundamental way possible. Beginning your einkorn experiment requires minimal investment. Search for einkorn seeds specifically labeled for planting rather than culinary use, since food-grade grain may have reduced germination rates. Several heritage seed companies now carry einkorn, and, online regenerative agriculture communities often share seeds among members. Start with a small test area, maybe just a single raised bed or a section of your garden that, really struggles with compaction or low fertility. Be sure to document the starting conditions with photos and some basic observations about the soil texture and how your plants are performing. As your einkorn grows, try to resist the urge to manage it heavily. This isn't a crop that needs a lot of pampering. It actually thrives on benign neglect, developing stronger roots and more robust microbial partnerships when it's just a bit stressed. Watch how it responds to your specific conditions, noting growth patterns and any challenges. Most importantly, observe what happens in the beds where you've grown einkorn when you plant your next crop. You'll likely notice faster germination, more vigorous seedling establishment, and improved plant resilience throughout the growing season. The regenerative gardening movement is growing rapidly, with practitioners worldwide discovering that the path to abundant, resilient gardens runs directly through soil biology. By choosing to experiment with einkorn and similar soil-building plants, you're joining this movement and contributing to a shift in how we understand and work with the land. If this approach resonates with you, subscribe to the Living Soil Lab for more explorations of ancient agricultural wisdom meeting modern soil science. Share this video with fellow gardeners ready to move beyond conventional approaches and discover what truly living soil can accomplish. Together, we're not just growing food, we're regenerating the living foundation that makes all life possible.